Hello friends, in today's video we will see how we can set up logging on Kubernetes cluster. We will take EKS for our today demo purpose, and we will set logging tool Elasticsearch, Fluentd and Kibana on Kubernetes. So let's start with the architecture diagram. Here is the architecture diagram. You are seeing there is no master node, as we are working on most of time on cloud system. In cloud system, either it's EKS, AKS and Google Cloud. Master node is the responsibility of the cloud. They are ensuring the high availability of the master. We don't have to think much about that. So what we are focusing on our worker node and on our application. So here you can see that if we start from node group, where we are collecting the logs, we have worker node. For example, we can consider we have at this time 2 worker node, and it is DaemonSet. Fluentd DaemonSet is running. DaemonSet means whenever the node increases, with respect to that, Fluentd will increase. When the DaemonSet we apply on Kubernetes cluster, it's ensure that one pod of that DaemonSet will be available all the time at that node. If we increase, maybe we will scale up and we become the 3 node, 4 node and 5 node. Fluentd number will also increase, and each worker node will have one Fluentd, one DaemonSet. So that's why we choose the DaemonSet as to ship the log. Why we choose DaemonSet? To ship the log, we need some agent at the worker node. And what is our agent? Agent is the Fluentd. Fluentd will ship the logs to the Elasticsearch, and from where that we will see. So this part is clear. This is the first building block of the architecture. We have we can say we have the total number of worker node, where we have the DaemonSet is enabled, through which we have Fluentd is available on all the nodes. So whenever the scale ups and whenever the scaled up, Fluentd will number will be remains same according to the number of worker node. So what is Fluentd is doing there? It's let's talk about what is the Fluentd doing. It's collecting the log and pushing it to the Elasticsearch. What log it's collecting? It's application log, the container log. We will discuss more about that. The path we will given from where it collect it and push it to Elasticsearch. So you can see that this all are just pointing towards the services of the Elasticsearch, and when they push the log towards the Elasticsearch here, and in the Elasticsearch, index is getting created, and if you working with the open search Elasticsearch, there are concept of indexes in the via day or with respect to all day. There are different indexes get created, and but this Elasticsearch, and if you see that is Fluentd is also pod, and this Elasticsearch is also pod. So if we are saving the logs here, that's okay, but when issue occur, like Elasticsearch pod got down, and data will also go down. So that's why we're using the PVC. I hope you have very much clear with the PVC. We have a separate video on PVC, how we can, what are the benefit. You can watch that. In this particular video, we are not going to configure one Elasticsearch. We are going to configure the 3 node cluster of in which one is master and 2 will act as a slave. So we so that if one node get down, other 2 will remain for backup. Service will remain up, logging will remain, and data they will store on PVC. So that's why we are making here the stateful set. We have seen DaemonSet. DaemonSet is making the single pod available on all single pod available on all the node. And what is stateful set is doing, like Elasticsearch is the database which needs its state to be persist, means it's require the data whatever is written. Maybe due to some reason it's got faulty, or somewhere due to some reason it's not working, and we delete the pod and the new pod will be launched. Master will be become other, but some pod will be launched. When the new pod will launch, state will remain same. If it's have we can say 15 lines of code, it will remain 15 lines of code with exact word. There will no changing. How we will get that? Main question is that how will we get that? We have PVC, where we are saving the data. PVC is not inside the cluster. It is a cloud storage for EBS, file share, EBS for AWS, file share for other cloud like Azure. We are making the PVC there and making our data to persist. Okay. And from here, when we are from here data, there it's collecting data, sending it to Elasticsearch persisting it data on PVC. When how can we see that what is the data stored there, and how can we do visualization? That's where visualization tool Kibana comes into play. Sorry, Kibana is come to play. Kibana is a stateless application, so that's why we go with the deployment, because it's don't have to maintain anything. It just have to, like me, when I am opening Kibana on my browser, I just giving a hit URL. It's getting processed. It will show me a web page, and through this web page, I'm going to set a option of discover. When it's going to discover, it's calling the Elasticsearch index, and through that, it's providing me the data. It's don't have any its own data. It's just showing the other database. It can work with all other databases. So that's the main working. There is a Fluentd. Fluentd is sending data to Elasticsearch. Elasticsearch is saving it through its configuration, making its charts, indexes, and then we are moving towards the Kibana. Kibana is for visualization. Anybody who is monitoring your system, who is the responsible for your system security, is a matching system through its log, whatever the alerts, where are they? Either they are going on Slack or other maybe email. So okay. I hope we are very much clear with the theoretical part. Now let's jump to the demo. My Kubernetes cluster is already configured. Let me check kubectl get nodes. Okay, it's working. So let's understand everything we are doing as in code. So let's start with the first namespace. Whatever we are doing, we are just doing inside a namespace. You know very well, namespace is just a logical boundary. I hope font is clear to you. You see it here. Whatever the manifest file you have, you just have to write it like kubectl create -f and ns.yaml. What it will do, it will kubectl is the utility that will send your request to okay. No issue. It's already created. Kubectl get, let's check the resources created there. Get pods -n kube login. It is not like that. If one resource is already created, it will again create the resources. So what it's saying, it's just saying that kube logging is also created, and we have checked there is no current resources are available. So we are done with step 1, we can say. Now we have to make, first we will create our foundation. What is foundation in our architecture is our database. So let's check with the database. What is database saying? Here is the YAML file of the database Elasticsearch. What it is saying that it's using the API version and kind is stateful set. Okay, then in the metadata, what we are doing is we are just giving this stateful set a name, and then we are telling that where you will create this stateful set in the namespace kube login. Then we have specification where we have service name given Elasticsearch, and replicas. We are creating 3 replicas, 1 for master, 2 for slave, and which replicas they will create who have the labels of app is equal to Elasticsearch. Then we are making a template who will make give the labels to its container of app Elasticsearch. Then we are in this spec, we are passing this to create Elasticsearch. It's giving its name container the Elasticsearch, and image it is using the public image of that particular Elasticsearch. Then we have given the resource limits of CPU limits and request. Then we have ports. It's for the REST API for the Elasticsearch. Then it will work on TCP protocol. Then we have container port 9300. It for the cluster communication. The 3 nodes have to talk with each other, so that's why we use that. Then we have volume mounts. In that volume mount, we have data of Elasticsearch. Where we are saving this data, we are saving this data in /user/share Elasticsearch data, and this data by defining it as an volume mount, this data will be get synchronized with the either ABS or whatever you are using, and it will become highly available and get independent of the pod lifecycle. Then we have some envs defined, cluster.name. They are taking the from field path method.name. Discovery.seed host. It's saying that we are making a stateful set, and in the stateful set, the name of the ports are very identical. Like we have given our deployment stateful set a name of Elasticsearch. It will create Elasticsearch 0, 1, 2, these, and telling him how to discover these nodes via this node only, because they are very identical in nature. We can predict them. They are predictable, and not like the deployment with the random hash value. They are very predictable. So main difference is one, that in stateful set we have the sequence, or we are predictable naming convention is there and very defined, but in the deployment we have just random hashes. Then we have some values initial, okay, because it will become the master and other will become the slave. Then we have some init container. Why we are using init container? They don't have too much do with the working of our application, but we have made this file, okay, and we are defining this file, and these files we are making the volumes, and this volume we have to work upon. V means Elasticsearch, and how will Elasticsearch will do work there if it's have the permission to work there. So what we are doing, that we are making the Elasticsearch the owner of that directory. So a read write operation can be done easily by Elasticsearch. Okay, we have even volume mounts here. Then we have given some parameter here. Why we have given this parameter? To set the kernel value. There is some preferable value from Elasticsearch. So it's prefer this value to work upon that. Then same, we are setting the limit. Then we have volume mounts. You have already seen Elasticsearch. Okay, read write once, only one person can read write. And resources, we have given 1 GB. I have given this low memory because I'm doing this for demo purpose only. There is no other. This is, I think you're clear to you. We have mentioned the volume mounts, but we have to define volume somewhere. So there, that is the volume we have defined for the Elasticsearch. Then we have the service. I think you are very much clear with this concept of service. Each deploy component in the Kubernetes cluster can't interact with each other without service. Service is like we are defining its communication, how it will communicate to other. And in the particular, I think we are just making its cluster IP. There are 4 type of services are there, and cluster IP is first type, which make the service communication enable inside the cluster. So whatever the resources are inside the cluster, they can communicate with the Elasticsearch on 9200, and on other port 9300. 9300 port is for their own cluster purpose, and on that particular node, anybody who want to communicate with the REST API of the Elasticsearch can do. Okay, so I think we are ready with the first our kubectl create -f es.yaml. We can give the name whatever you are doing, just do it inside the kube login. We have just created this namespace. Okay, sorry, we have done there. We are not at same directory. It is in final es.yaml. Okay, what it's saying, that stateful set is created, service is created. kubectl get pods -n kube -logging -w. See here, 0 comes in running 20 second. It happen after that, it second one is come up, and then now we have 3 come up. So why I'm showing you this, because when we run the stateful set, what happen is first port with the 0 in the last, will create it. If it's not get created, other will not get created. First it will comes in running state, then other will start its process of pulling the image, then starting the container and coming in the running state. Then third will become in the same way. Neither they will create it at same time, first, second, then third. And in the deployment we see all of 3 comes live at same time. We will see that also. So we don't need the watch command. So I hope till now you are very much clear with the Elasticsearch, what we are doing through this particular manifest file. We have checked that ports are working. Now we don't need this, just verifying this service. Okay, Elasticsearch cluster IP service is not get created. 1 second. Yeah, it's get created, it's there. External IP is not showing. Okay, no issue. because it's not showing because it's a cluster IP. If there is a load balancer we choose, then we surely have that here, the cluster IP. Okay, let's move to the next part. uh, we Let's do the EFK one. So EFK, what is EFK doing? uh, it's talking with the Kubernetes, okay, and taking the Kubernetes logs plus node log and pushing it to the particular pod, Elasticsearch. Okay, so what is the issue here? To talk with the Kubernetes API and to send the logs, we need some permissions, and and you know very well how to give permission to pod to do some stuff in the cluster is via making service account. So via making service account, you can talk with the particular you can talk with the Kubernetes API. So first we have created the uh, service account, then we are making the service account via name of Fluentd. Inside the kube logging, I just explained this. It's the API version kind is service account. So when you are creating service account, you have to keep that. Then metadata, you're just giving the name under namespace and giving the labels to. Then we are having our next. Actually, we can make it a different manifest file, but I covered the same kind of manifest file in one file. So here we have the API version, kind is cluster role. If you see here, we have given the namespace because service account is specific to namespace. But when we are talking about cluster role, how can cluster role be specific to a particular namespace? And we have to logging monitoring to whole cluster, not particular namespace. So that's why we are using the cluster role. What is this cluster role doing? It's saying that to all API groups with the resources, ports, and namespace, you can do get list watch. You can perform these. If I just make this below now, we are defining a cluster role with the name Fluentd with this label and API groups all and resource. We are giving this ports and namespace. What it can do, get list watch, it can do. Okay, but you can see it is different. There is no, we have not talked about anything service account. That what we have to do, we have created a service account. We have to give this permission to service account to because service account needs to do these steps on the cluster, this action on the cluster. So what we can do, we can create a cluster role binding. Cluster role binding is the way of giving service account or giving service account cluster role actions or whatever rights it has. So it's, we have just defined a cluster role binding and API version, then we have given a name, then we have given role reference cluster role. What we have given the name of that cluster role is we have given the Fluentd. Then we have the API groups there, then subject, under subject to which service account we wanna give this particular service account. Is that service account Fluentd kube logging namespace. We are just saying that service account name Fluentd in the who is in the namespace of kube logging can use this cluster role at all the action. Then okay, this file have some issue. Then I have created this file. This file is saying that we have the API version v1 and we are creating the config map. Config map we require to define what will be the input, output, filter, what things to be sent to the Elasticsearch in what format. We have to define that. So that's why we are choosing this. Okay. Fluent bit configuration, we have passing it. We are making config map. Config map, I think you very much clear the config map. Config map is the properties or some small files which we keep in the etcd. All the config map will remain in etcd. Why we do that? There are some we can say there are some cases like we can keep the Elasticsearch file also. We have seen recently we have made a video of Prometheus where what we are doing, we are making the Prometheus config file as an config map and passing it. Whenever the pod get down, it will it will take the a new image, and all time we have to pass the configuration because we have to add the alert manager plus Grafana ID Grafana we don't have to, but we have to make some changes like we have to make service discovery. If we are not making service discovery, then we have to make some hard-coded value there if we are not preferring the not able to do the service discovery. So point is simply is that to save our configuration file, to make it independent from the pod lifecycle, we use to save the configuration in config map. Okay, we are very much clear with that. I hope I'm able to make you clear on that particular point. This configuration file will take, this is the path of the log where it is taking logs from /var/ all the containers, because in the end we have the container in the running in the pod. We have to take its log, and that's the DB where we are on interval. Then we have EMPS. Okay, I've just made some changes in there actually. Then we have output classes .conf name is okay, Fluentd classes host user password parse.conf, whatever we things we want to parse. Okay, then finally we have the DaemonSet. We have already talked much about the DaemonSet. We are defining it by using its kind. Then we have name, labels. We're just giving the name, version, and making it true. Then we are in the specs, we are making its template that v1 that's true, using its public image. Container port, it will listenable on 2020. Then we are some passing the environment variable. Here you can see that it's our service. Then we have our namespace name. Then as we see cluster.local, it is the way of calling a service from to just if we do HTTP curl that you can able to hit the okay, we are calling its API on 9200 port. Then we have mentioned the volume mounts /var/log in the where we have seen the logs which contain the logs of the container. We are mounting the path, then termination grace period. So some passing some toleration with that. So this is the configuration file of the Fluentd, which if you see which basically depends upon the service account, cluster binding, and some configuration, which are the backbone of the Fluentd. That's great. It is EFK .yaml in the namespace kube logging. Okay, we can see get ports. We don't need this time -w. Okay. If you see that, that's what I'm saying. If you make the deployment also, it will create at the same time and with the random hash. And you can see the value here is in a unique order, predictable one, whatever the over your primary node. So that's the main difference I was talking about. So now till now we have done with the two parts. Let's complete the third part also. If you have any suggestion, any feedback about if I can improve myself to give you more information, what I have done, so please you can comment about that. Then we have API version V1. We have defining a service for Kibana in the name login. Then we are giving label and giving its port 560. Okay, then we have apps V1 deployment. We are making its deployment Kibana kube logging just with the replica one. Either it will get deleted or down someday. It deployment feature will make will launch the new pod and it's stateless, so we don't have too much worry about that. Selector, match levels, template we are passing using the public image of Kibana, setting this resource limit. It's best practice to define the resource limit. And then we have env, Elasticsearch, 900 Elasticsearch. It is the API of the Elasticsearch. Then we have the Elasticsearch URL. If you see that it's hitting its own Elasticsearch, that service colon 900, and its port is 956001. Kibana configuration was very straight and simple. Let's create it. Here we pass the Kibana. Okay, it's saying that service Kibana is created, deployment and both are created. Get ports. Okay, it's in running state. Then we have SVC. Okay, both Elasticsearch and Kibana we are doing. If we have to now, we are done with the installation part. We have to edit service Kibana. It will give you view like that. Go below. Actually we have made the file of cluster IP, but we have to access it from outside. So what we can do, we define it as node port. It's second service, third service the load balancer, and fourth is the external name. Okay, let's see. Okay, it gets created is port 30042 and I have to access it. Okay, sorry, we have to get ports -o wide. We need IP address of the machine. We have, okay, where is the Kibana running on the 41. But we can do more. We have to do find the external IP, get nodes -y. So that is the external IP. That is our port 30042 and that's our node. Just go to the browser and make it run. Okay, sorry. Okay, Kibana is getting loaded. Its has is like when we hit the nginx, it will get hit at slash, and it's by default it's redirecting us to /app/Kibana. Wait for it, it's get loaded. Okay, it gets loading. It's the front end page of the Kibana, but what where we are instead on, go to setting, and here you will find index pattern, and under index pattern, if everything is perfectly fine, whatever we have done, here we will go to the create an index pattern, and you will find here the pattern like that, log stash. What you have to do in the log stash, and then you pass the asterisk. Why? Because each day new index will be created, so you don't have to make the index pattern again. It will not good for the visualization. If you want a stat graphs for all the indexes, so you have to do in that way. Then in the next step we have the timestamp. One second, and create new index pattern. Hope you are watch like 1 second. I hope you are happy to see this video, and it will helpful for you in your project, because logging and monitoring, the two parts which are very essential part of the. Okay, what we are getting, timestamp log studio out. Okay, they're just we're getting, we have to what we have to do, we have to make it very unique, customize as per our way. Actually, if I tell you, if you think that it's getting created from very early of time, what happened is that we have created the particular EFK for demo process, but I have tested this configuration before the demo, so PV was already there, some previous data was already there, and new data is also coming, so it's working fine. But when we can manipulate that to check maybe it's work or not, that's the last thing I have. We have a busybox image, we which run a continuously loop for saying thank you for subscribing, tag on target. So I hope, and I'm also hoping that you will subscribe our channel. So it is an API version v1. We have just kind of board, we just have to demo this thing. It's not part of the project, we have just seen this thing. 1 second. Okay, kubectl create -f test board. We are not going to create it in the kube login namespace. Why? Because I have a issue like that. We have to monitor the whole cluster, not only kube logging namespace. And if I create this in kube logging, so someone can get confused that we are just monitoring that particular namespace. And let's create in the default. Okay, and list it kubectl get pods. Now I don't have to pass the namespace extra, because if I don't pass anything, it will take default as a namespace by default. Okay, it's in running state. Okay, check what is busy box is doing, it's continuously creating a log of saying that thank you for subscribing our channel. So let's see here the logs come or not. Okay. Let's wait for it. Logs are continuously coming, but it's not able to read that. We have to configure the Fluent. We have to change some that particular config map. We have to change it to get this format accepted. So we will see that in next video. Hope you like it. So thank you for watching video. If you have any suggestion, please comment. Bye bye.